Hi, welcome to this evening's edition of the Build Tech Talks. My name is Sjoukje Zaal and I will be your host for this evening. This evening is all about test automation. Our speakers will give you their view on consumer-driven contract testing and maintainable test automation. So we have two amazing sessions tonight. Gerwin Vaatstra will kick off by covering consumer data, consumer-driven contract testing, and why you should put your consumers first and your APIs second. Next, we have Joost Arends, and he will talk about how to set up maintainable tests. So before we start, we really love sharing our passion for tech at Capgemini, inside and outside of it. Because of the current pandemic, we are hosting this meetup completely virtual. But in the future, we are planning on doing a mix of meetups. Some will be virtual and some will be hosted at our office in Leidse. All these meetups are, of course, completely open for everyone to join. So if you have any questions during these sessions, please ask them in the chat and I will pass them on to the speaker at the end of each presentation. So without further ado, I want to introduce you to our first speaker, Gerwin Vaatstra. Hi, Gerwin.
Hi, Sjoukje. Thank you.
Hi, how are you?
I'm doing good. Bit nervous, but it's a presentation that I did a few times already, so very happy to do it again.
Okay. So what do you do in your day-to-day job?
In my day-to-day job, I'm a test automation engineer. I worked for Capgemini for more than 7 years and specialized more in CI/CD test automation, and therefore also came across consumer-driven contract testing. That interested me a lot.
Okay, and you also do that at customers often as well?
Yeah, I do that. I've done that for various customers and various environments, and mostly CI/CD in the last couple of years.
Okay, nice. Okay, so the floor is yours. Good luck.
Thank you.
With your session.
Thank you. So good evening, everybody. As said, my presentation is about consumer-driven contract testing and why I believe consumers should be first and API second, contrary to popular belief that API should be first. So who am I? I'm Gerwin Vaatstra. I've worked for Capgemini for more than 7 years now. I started with manual testing, then on to test automation, lead for web development, and DevOps tester, and now I was a quality specialist for different customers. And what I really like to do is to strive to facilitate, to perform. So I don't want to be the only one that tests. I don't want to be the only one that knows how to test. I actually want to work with the team to deliver a lot of value, and by doing what I do best is focus on quality, focus on value, and focus on how we can work together. My passion is knowledge sharing, and therefore I like to give presentations, but also give trainings for the Capgemini Academy. And also I like to build a community around knowledge sharing and also help each other out. So it's a broad area that we work in, and there are so many specialties that it will be awesome if we can just help each other out and benefit from each other. Sometimes I have a bit of issues with dealing with impediments. Generally, I'm more enthusiastic about the quality than developers, but contract testing is an area where that can be less, but also can be an area where developers say, "Nah, I'm not sure this is the right way to go," so that makes it interesting. So what are my experiences with contract testing? It started with a client a few years ago, and they said, well, it's interesting, but I think we shouldn't do it. I tried to convince the developers a few times. Was part of the lead developers talks that we had every week or 2 weeks. And every time I went there, I convinced the developers, but then came back and another developer said, well, I'm not really sure. At the end, we decided to do it. And then when we had to take it in sprint, my team said, well, I think we shouldn't do it. So then another client that I worked said, well, it's interesting indeed, but let's do it when we finish the services and the APIs are final. So they did see that it could have value, but they saw it as an overhead while developing new functionality. And also, I've been to a few DevOps meetups that talked about microservices architectures. There are a few good series on that. And a few times I heard companies or developers talk about how they had everything in place, like infrastructure as code, a full CI/CD pipeline, a lot of automatic testing. And I heard two people separately say, we have everything in place, and there's one thing that we're not really sure about is like contract testing, and we're really curious about real-time real-world experiences with that. So there was a lot of talking about it, but there was not that much experience in contract testing. So what I want to do in this presentation is to first elaborate on what contract testing is, then when and what to test, the difference between consumer versus provider-driven testing, also API design, also contract testing, the development process, how does it fit in CI/CD development, some last remarks, and if time let me, then I will show a few code examples to illustrate what it is. But this presentation is mostly focused on the concept and mostly focused on why and when you should do it instead of the code examples. So my definition of contract testing is obviously taken from a few other definitions, is that the use of verified mocks and drivers, which contracts are specified by example in code for integration of two applications and which verifies the syntax of interactions. So important point here is that it's verified, and I will come back to that later. Of course, you can use mocks and drivers, but the benefit of contract testing is that it is actually verified on both sides. And the contracts are specified by example, in contrary to many clients where I saw that they documented it on a wiki, for example, Confluence. Here it is actually specified in code and by example. And it's interaction between two applications, but it focuses on the syntax of interactions and not as much on the data. All this comes back in the presentation. So integration testing and use of mocks. So if we do integration testing, you have a consumer and a provider, and there's a real interaction. If you use mocks, you actually say, well, let's put something in place, and that verifies as a driver or as a mock. In this case, actually, it's more like a driver. But it does not verify the response if it fits. If we look at contract testing, you still have obviously your actual interaction, but that actual interaction is saved in a contract, and that contract is replayed at the provider. In this case, again, as a driver. So, where in the previous example, you build a mock and you say, well, this is how it should. This is the message it should send to the provider, and the provider can test itself. In this case, it is verified on both sides, because on the consumer side, you verify that you get the actual response, and that actual response is verified on the provider if it is actually sending that response. So where's contract testing in the pyramid? I believe everybody is familiar with the testing pyramid. And I would say it's between unit testing and integration testing, and it's not as much as a separate layer as it is integration, as it is said here. It can be on the unit testing side, and it can also be more like the integration testing side. Fact is that it will take a few of your integration scenarios and will be put in contract testing. So you will get less integration tests. It does not replace integration tests, but you will get less integration tests. And on the level where it is executed, that can be different. And I have another slide about that later in this presentation. So an important law you come across is Postal's law, and it's much about API design. It's about contract testing as well. It says be liberal in what you accept and conservative in what you send. So if you put that in contract testing, you only ask what you need. So if you have a service that gives you a product, but you only need the price or and the name, for example, don't verify that your response also contains the supplier or any other information about the product. Only verify what you need, and only ask for what you need. And be losing what you reasonably can accept is actually what I explained. Except also if there's more information. If the information is there that you need, that's fine. But don't verify if it fully complies to a schema or example. For example, just verify that your information is there. So that opens up the way that if nobody's using the extra information, then the provider can actually delete that from the response without anything failing, without anything breaking. So once you establish that you want to do contract testing, and you establish that there's a benefit in that, then there's some different options on how much you want to test. So you can choose the whole service as a black box. So input output testing of a service. That's an option. You can also test a part of the service. For example, that you receive a payload and save the data in a database, but if that would trigger an event send out or trigger anything else, you will mock that out. So it does not act as a full service, but you test a part of your service until you're confident that the payload or the response or the whatever is input can be handled by your service. You can also choose the more the purest way, I would call it. If you look online, you will find that most say this is the purest form of testing. You only test the controller of your application, the only where it enters your application. And then it can also be on the unit testing level, which is obviously a fast and reliable level of testing. In my example, in my experience, I chose the second one, the testing a part of the service. I had a Spring Boot application, and for those who are not that familiar with Spring Boot, or those who are, there was some configuration in Spring Boot that in this case, a transformation of date time. And therefore, I needed that context to be sure that I could handle that payload. So I chose to spin up the Spring Boot service and then receive the payload, see if I can save it to the database, and then stop. Why I chose to save it to the database was that I wanted to be sure that the payload that I received and was transformed to an object could actually also be saved in a database. So it was not that much more effort for the value that I was getting. And that's why I chose the second option. So my presentation also encompasses some that I should choose for provider-driven versus consumer-driven. That I would choose the consumer-driven approach. And in many cases, you see a provider-driven API design. Important to note that contract testing is only sensible when you both have the consumer and your provider in scope as an organization. For example, you cannot be an Amazon or a Google and use contract testing for the APIs that you expose, because you don't have both. You cannot really verify on both sides, because I might use a Google API, but I can say this is my contract, verify it for me, but they will probably say, well, good luck with that, but this is our API and here's our documentation. So the provider-driven approach is mostly that we say this is our service. That's mostly where developers start. This is our data model. That's also what you see a lot. And let's expose our data model as much as possible. That will result in this API. And then we tell the consumers, this is the API. This is how you use it. Here's our documentation, either in Swagger or on a wiki, for example. And you have to comply, and if you don't comply, then you have a breaking chains, and consumers just have to adapt. If you turn it around, you can also choose to start with consumers, like what do I need? What is it that I need from an API? I will write that down and deliver that contract, or actually specification more, to the provider, and they can verify if they comply. Now, that does not open the way that consumers are king in this case, because it's still a mechanism for communication. It's not that consumers dictate how an API should look. You can still say, well, we have another API, and can you use that field, for example? And then you can adapt and get a working example. There are quite some benefits in it, but I will come back to that later, how this can also benefit the development and spot mismatches or miscommunication early on. Important to note here is that the API is also aware of its consumers. If you took the provider-driven approach, mostly you're not aware of what consumers use of your API. It's possible, but mostly you're not aware. In the consumer-driven approach, you have like 5 contracts, so you exactly know who uses what of your API. So this is a practical example from a client that I had, and the client used trains. And what we had to develop was that we would get some source information about the train times, so the times train arrive at the station, leave at the station, etc. And it was also about the material, like what sort of trains, the length of the train, etc. And we would receive that from an external party, and then we would save it in a database. Then that database would send out an event if it had new information. The adapters would get the information and post it to both of the services. Maybe good to say, I was not very fond of that architecture, but that is the architecture that was chosen. Good to know. So important to note, both services had the information, and then consumers could request that information. And there was a train rights adapter in between that would combine the information from the train time service and the train material service. And there was one particular part of the information was the stop types, and that stop types included things as stop for passengers, or only for personnel stop, or there was actually also a stop type that said stop for delivering of post. So there were 7 types, but the consumers only needed 4. They only needed to know if you, because it was for domestic traveling, they only needed to know, like, can I enter the train, only enter the train but not exit the train? Can I only exit the train or not enter the train? Can I both enter and exit the train at that station, or can I not enter or not exit the train on that station? And for example, sometimes you have international trains that stop at stations, and then you can only exit but not enter. And there are also stops, for example, only for personnel, where travelers are not allowed to get in or get out. So in this case, the team was responsible for showing information on the screens on the stations. Therefore, they only had those 4 options that they needed. If we have started with the consumers that they needed that, and we knew fairly well that was all the information that we needed later on in the chain as well, we could have chosen to do the transformation already early on. But because we chose the way like we get the information, so we save the information and we expose the information. Both consumers implemented the 7-to-4 types conversion. And at the end of the project, we actually said, well, that's not nice. And we had to change both consumers, change the train rights adapter, change the train times service actually as well. So it was a lot more work. That was the moment that I said, well, I told you so, but that was not really that they liked to hear that. But this is an example of where contract testing would have helped you with your architecture or design. So I already mentioned a few times that mostly we start with API design, that we look at our data model and see what can we expose. And then we expose a lot of information and we don't know who's using that. And we have to put extra development in keeping it working. So there were some statistics, maybe a bit older, in 2010 that in custom software development, I think 50% of functionality is hardly ever used and 30% is infrequently used. And that's big numbers if you also have to take into account that you want to keep that working and you need some people to, you actually don't know who you're developing for and therefore you develop too much. And I think contract testing can help in that way because you know more about what is needed and can only develop what is needed. It's actually more of an agile approach, so you only develop it when you need it. So a common scenario when you have new development, when you have new functionality, that new service or new functionalities, that you discuss the requirements and you document it somewhere, especially if you have two teams working on the same application or if there's an interaction between two applications. Then mostly you build separately. The application is not ready yet, so in integration testing phase, that both applications are somewhat ready and you could do an integration, then you will see, well, actually, I thought you would send me the date in this format. And then, well, I thought we would agree that we should send the date in another format, or we didn't document it because it was so obvious that we would send you the date in the international format or in the with an offset or without an offset. And then both teams go back to solve their own bugs, their bugs that are on their application level. And then you test again, see if it works, and then discuss where it went wrong, because there was documentation, and how come that we didn't spot it early on. Mostly because you start with the API first, and then develop, and then there can be new insights. Also, there's also an option: new insights, new requirements. Because once you're working on your application, you can see, well, maybe we can do it short. We can take a shortcut here, or we have a different need actually. So yeah, if you start with the API first, then that can happen. So if you would look at integration testing versus contract testing in this case, then from the perspective of functionality ready, in the previous example, you can only test in the integration layer when most of the functionality or a big chunk of the functionality is ready. Well, if you compare it with contract testing, you can already have the contract ready, and both sides can verify if it works, and you don't need a full-fledged application yet. For the data, for integration testing, you need a set of data that can be established, so you get the correct response. For contract testing, both sides are responsible for their own data. As you remember, maybe I said contract testing verifies the syntax of integration, not the data. So it verifies if the name field is a string of a specific value or that it contains specific characters only, but it does not verify if it's always Tim or it's always Jack. Also for running services. For integration testing, you need both services running and therefore a lot of functionality and data ready, and then both services need to be running. It's a higher level of testing, more overhead, and therefore more less stable and more expensive. For contract testing, you only need your own service running, and the mocks and the drivers are handled by the framework. And lastly, what if you have dependent services? I've heard from clients that I worked for before that they had an environment where a lot of that was constantly down because dependent services were down, and therefore the environment was not usable anymore. With contract testing, you can only stop out that service, but if you use integration testing, that service might need another service and another service and another service. So that domino effect is not happening in contract testing. So if we look at software changes, then you also start with the information needs. You might change your provider. Somebody wants something else from your provider. Then you have to look into who is using your API. If you add information, that's fine. Obviously, if everybody adheres to the Postal's law, then if you add more information to your API, nobody will break. But what if you want to change the format of the address or the format of the name, for example? That is difficult if you don't know who's using your API. So if you want to do a breaking change, everybody advocates that you should not do breaking changes. But if you need to do a breaking change, or if you want to change something because it's more efficient, then you need to communicate the new API definition to your consumers that you had to find out. Maybe have two APIs in parallel. And then you also need a timeline that people switch to the new API. And in the meantime, you have to maintain both APIs, and also you have to do work afterwards to clean up the old API. And many times you find out that consumers don't have time to do the development work, and they need more time, and then you have extra communication about what you need to deprecate the old API. Not ideal, I would say. So if you take the API first approach, then you change the API and you have to adapt. And in this case, mostly you don't do that because it's a bit of harsh to say this is the new API, everybody changed now. And a breaking API change to be complete is if somebody uses it, it can break. You don't know if somebody uses it unless you research that. But so how would the workflow be with contract testing? So given that there is already a working interaction, a working integration between two services, maybe consumer one wants something new, and that might already work. So he can, for example, he gets product information already, he gets the name of the product and the price, but now he also wants the quantity. Well, maybe somebody else already wanted the quantity before, and the quantity is already in the API definition. He updates its contract, and that works fine. New contract still works, no change needed in the provider, but a new contract is delivered. So the provider knows that also this consumer one now uses quantity. But maybe it's not already there, and then the provider changes. And the provider, given that he knows he has all the contracts of all the consumers, sees that consumer 2 is working with the provider, and then that's fine. Consumer 2 has the same contract, still works with the new provider, and so both consumer 1 and 2 are happy, and the provider made a change and knows that it should work with all the consumers. But it can also be that if you change something for consumer 1, consumer 2 is not happy anymore because it might break. Then the provider is already aware of this. It's important to know. The provider is already aware of this before it goes live, before it goes to integration testing, because he already has the contracts that he can replay all the time. And then he can obviously choose two options. He can make a patch or so that both work, or it does not have to be a patch, but in this example it was easier to illustrate. Or he can discuss changes with consumer 2, and then consumer 2 can make a new contract. Then the provider will see, okay, now both consumer 1 and 2 are working, and then go live, and then both consumers are happy. So you can never really have a breaking change if you do this correctly. It's easier said than done sometimes, but this is a kind of a good approach to never go in production and see that it fails. So we already saw the testing pyramid, and in CI/CD, obviously you test you have a lot of automatic tests, and mostly during the build phase and unit test phase, you can do that locally or on a build node, or you don't need a running application for that. And for service testing, that can be something in between sometimes. And for integration testing and end-to-end testing, you need an integrated environment where other services are present. If you compare that with contract testing can mostly be done locally as well. You don't need other services for that. Sometimes you can spin up your own service, but mostly that is easy on a build slave or a separate environment. And then only the service testing is again in between. So you have more on the local side. Still, you have the integration testing phase, but there will be less scenarios there because you already know that the syntax is working. So now you maybe want to do some extra tests for security or for infrastructure or routing, or maybe timing. Timing issues can not be found with contract testing. If you have a service that needs information from two other services, that can be a timing issue that you can find in integration testing, but not in contract testing. So the workflow here is illustrated with Packflow and with a broker. And Packflow is actually the hosted service offering of Pact, and the Pact broker itself is open source, and you can use that in your own environment, whatever you want to run. It's a Docker container, easily to run. And what a broker does, either the hosted variant or the standalone open source broker, it's nothing more than saving interactions, saving what is the request and what is the expected response, or what is the event and what is the expected result. And the broker has some extra functionality there. And for example, you can have an overview, which services has which consumers. But if we look at the stages that you go through when you develop with contract testing, then you have the build phase, you do your isolated tests, and then you generate your Pact. That will be sent to the broker, and the broker knows if this is a new contract or it's already an existing contract. It will not validate all the contracts every time again, because he knows, well, there's nothing changed, or this contract is already verified, so I don't need to verify it again. But if it needs to verify it might verify the Pact on the provider side, and that's mostly done by a webhook. So a webhook will trigger a build of the provider, and then we go to the provider side, and that provider side will mostly have a separate build phase for the contract test. So you don't need all the tests done. You only need, for example, Spring Profile to only run your contract test, and that will publish the results back, and you'll see that in 3.0 publish results. And once that is done, then the consumer can resume. So in Can I Deploy, that's actually a common command line tool. They called it Can I Deploy. It will constantly query the broker, like, is the contract verified? And if it's verified and it's correctly verified, then you can deploy to test. If it's not correctly verified, then you already stop before deploying to test. So you will not demolish your test environments again. You also see the tag, and that is Pact uses tags. So you can say, well, this version of application A uses this version of application B, and that contract is valid. So you can have a contract that works for the test versions, but not already with the live production version, for example. So by using tags, you can see which versions work together well and which versions might not work together well yet. Well, and then after you deploy to test, integrate the test, and then you can have maybe another query again. That's in the second Can I Deploy. Does it already work for production? So yeah, then we can go to production. If it does not work for production, then we don't go to production. So that is if a consumer changes something. If you go to the provider side, they will do the isolated tests, and then they will verify all the existing contracts. They will then query it, like, is it done? Is there anything new? Any new consumers that we haven't verified yet? And then they go on, just like on the consumer side. So the provider side never have to trigger a consumer, because they already know all the contracts. On the consumer side, you see that it might trigger the provider build, and that is because it's consumer driven. The consumer starts with a new contract. So if there's a new contract, then you need to trigger the provider to see if your contract is working. And there are some there are some options to store the contracts. You can store the contract at the provider side, and then in the provider repository. Then the consumers will all have their own contracts in the provider repository. If you want to do consumer-driven contract testing, then all consumers need to make a pull request, for example, at the provider, and say, well, this is my new contract, and that is an option. I would not recommend it that much, because I see more benefit in a shared repository, because then you also have more shared ownership of that, and it's easier than to have it at a provider. When you have a shared repository, you have a better overview of the interaction, and also a better place to go looking if you want to get an overview of the architecture. Both will get and push their contracts to the shared repository. The third option that I would mostly advocate for is use of a broker, because you get some extra options there. Like an overview, it's always live. You don't need to get the contact from the repository, but it's a simple API call. The Pact broker is actually using REST, so you can use a lot of functionality to update the contract, or to view who the consumers are, who the providers are. There are a lot of options in Pact for that. So a lot of information about contract testing, and then mostly there are some issues like what it is and what it is not. Like I already said, it's only when you have both provider and consumer in scope. The benefit of contract testing is that you specify a contract in code, and it is verified at the provider. If you don't have the provider in scope for your organization or for your team or most of your organization, then there's no benefit in that, because you cannot communicate. You send the contract into nothing. So only use it when you have the provider and the consumer in scope, and you can actually do something about failing contracts. Elsewhere, it's useless to see that a contract is failing if you cannot do anything about it. And it does not fully replace integration tests. It validates the syntax of integrations, but not the data. Also, integration tests have value for other things, like can service A reach service B? You cannot find that you cannot fix that in a contract test. It simply needs the whole routing, the whole architecture, whole security with tokens or SSO maybe. That needs to be done in an integrated environment by integration tests. It's not only the developer's turf. This is actually, hopefully, it's not new information, but this is actually rather consumer-driven, business-driven. You indicate what you need from a service, and a lot of people can think about that. A product owner can think about that. A business analyst, a tester, all have some sense on what you would need from another service. And I think this is a great way to stimulate interaction between both developers, testers, and business analysts and product owners, because it is specified in code, so that's really on the developer's turf to develop it in a sensible way, but it actually says something about functionality and business value, and therefore it's not only on the developer's turf. And it's a facilitator for communication, but it's not a replacement. It's not that you publish your contract and say, this is it, deal with it. It is actually, this is our contract, and then the other party can say, well, we already have an API. Can you adjust it maybe so that it works? I've talked mostly about Spring Cloud, about Pact, and there's a second big player, and the Spring Cloud contract. I made a comparison quite some time ago, so maybe this is not all actual anymore. But these are the most of the differences between the two tools, the main differences. Spring Cloud stores the contracts at the provider side. It also chooses more of the provider-driven approach than Pact, who clearly chooses consumer-driven. Pact is better at events because it also validates a routing key. A routing key is like a tag to an event or to a message, and Pact does not validate that. So you can have an event sent with routing key A, and then it will never reach application B if it listens to a routing key B. There's a mismatch, and it would not reach each other. Like I said, Spring is more provider-driven. It is compatible with Pact contracts, but not the other way around. So if you have a Pact contract, it can be transformed to Spring contract and used, but you cannot transform Spring Cloud contracts to Pact contracts. There's no broker for Spring Cloud. Less programming languages is mainly Java. And while Pact has a lot of programming language, Java, but also JavaScript, so this is really a good way to have a front-end and a back-end validations. And of course, its integration with Spring is a lot better, but it uses WireMock compared to Pact. And Pact uses, not fully sure actually what Pact uses now. I forgot about that. So this is mostly my presentation. I'm curious if there are actually questions or something that I have to elaborate on.
Yes, Gerwin, very interesting session, really. I did a lot of integration projects in my career, and there wasn't that much focus on contract testing, and that's really a shame. I think a lot of issues could be solved by focusing more on that. Great, really interesting. We have a couple of questions. Let's start with the question of Rutger. Rutger says, I understand how contract testing can work on API and on system test level, where the contracts are easily definable. But can you implement contract testing on end-to-end test level when the contracts are harder to define?
It's not meant to be implemented on an end-to-end test level. because end-to-end testing you mostly do to verify a chain of interactions. So if the question is that, for example, that you want to place an order and you want to use contract tests for that, it is actually meant to test the interaction between two services or two applications, and not a full end-to-end cycle. That would maybe comprehend you would have obviously contract tests for the different interactions, but it's not meant for end-to-end testing.
No, I understand. Okay, because you're not testing the code, the actual code and the actual function, only the contract. Yeah, I get it.
It would be the same question if you could say, can integration testing be used instead of end-to-end testing? And there are some use for end-to-end testing. Why don't you integration testing? And this is below integration testing, so no, it's not usable for end-to-end testing. Obviously, you can question if you have too many end-to-end tests, and that can be downscaled to integration tests, and then you can have a look like, well, which integration tests can be used to convert to contract tests.
Okay, yeah, okay. So we have another question from Christian. He says, having front-end calling back-end, say REST API, where to handle the contract tests? On both sides?
Yeah, actually, you want to do that on both sides, because and this is actually a pretty good example. Obviously, you have a front end and a back end, and the back end is sending some response based on the front end call. That's mostly the case. So the front end will specify which call to make to the back end, and specify which response it might expect from the back end. On the back end, you want to see what are actually actual calls to the back end, and you can verify if that results in the expected result. And both can do that on their own, but they don't have to be live running simultaneously. Both can do that when they make a change to the application.
Yeah. Okay. Interesting. Okay, so that are the questions for now. Thank you very much for this session.
You're welcome.
Yeah, very interesting, and have a nice evening.
Thank you.
Thank you. So our next speaker is Joost. Hi, Joost. Welcome.
Hi, Sjoukje. Good evening.
How are you?
Yeah, I'm good. I was just reading up on that our lockdown is extended for another 2 weeks, so I was a little bummed out about that. But I'm excited to go on with my presentation. So yeah.
Okay. You were supposed to do this presentation together with Mazin, right?
Yeah. Unfortunately, he couldn't be here tonight, with good reason. Actually, he became a dad last week, so obviously he has other priorities at this moment.
Yeah, that is a valid reason. Yeah.
Yeah,
I
exactly.
agree on that. Yeah. Yeah. So you are a big fan of automation, am I right?
Yeah, definitely. I haven't been in the field for that long, but the moment I rolled into testing, I immediately specialized into test automation. So
Okay.
that's definitely where my passion is. Yes.
Nice, and a very, very good passion also for clients, right?
Yeah, very useful, I think. Well,
Yeah.
I mean, if I didn't think it to be useful, then how can I convince my clients to be? So.
Yeah, that's true. That's true. So you're going to talk about how you can set up maintainable tests.
Yeah, exactly. And well, I don't want to spoil too much, but I think every one of us has seen some implementation of test automation on one of their projects, which hasn't been too successful. So hopefully I can give some, some tips on how to keep it maintainable and how you can make it successful.
Okay, let's see. The floor is yours. Good luck.
Thank you. All right, welcome everyone. Welcome to my presentation on maintainable test automation. Like I just said to Sjoukje, this presentation was inspired basically by test automation projects that both Mazin and I worked on, where we saw that it didn't quite deliver on the return of investment that was expected, or deliver on the expectations as a whole. So what I'm going to do is I'm going to give you some tips and tricks on how we feel that you can keep your test automation project or implementation maintainable. But let's first start with some introductions. My name is Joost Arends, and I live in Amersfoort, which is a beautiful city, as you can see. And like I said to Sjouki, I haven't been into the testing profession for that long. I actually started my career in education. I've been a chemistry teacher for about 6 or 7 years. And in that time, I did a lot of things. I worked mostly in secondary education, but also in higher education. I co-authored a couple of books at an educational publisher. And at some point in time, I figured I've done most of the things that I would like to do in the educational field. So I was on to a new challenge. And more or less by happenstance, I got into contact with a recruiter and I ended up at Capgemini. And I've been enjoying my time there ever since. I immediately specialized into test automation, which we all know is a field where there is a lot to learn, a lot of challenges. So I haven't had a chance to get bored yet. Like I said, I would do this presentation with Mazin, and we both worked very hard on this presentation and on the tips and tricks that we would like to provide you. So I wanted to leave this slide in just to give a little shout out to Mazin. And I'd say let's start. If you look at the main topics that I would like to address tonight, I would first like to talk about the common issues that both Mazin and I saw on the projects that we worked on. Then we're going to dive into a little bit of test automation architecture, because we believe that is an important topic to make your project successful. And what we did to give our presentation a little bit of body is we put the tips and tricks that we saw into a sort of commandments, which happened to be 8 of them. So we titled those the 8 commandments of test automation, which will be the main topic of this presentation. So let's first dive into those common issues, with the first being reusable keyword-driven steps. And we're talking about the test specification here, which for most of us would be in a given when-then format or in a Gherkin format. And what we saw on a lot of projects is that those keyword-driven steps were implemented in a way that they were reusable. So they were on a very atomic level, and you could use the same steps on a lot of your test specification, a lot of your test scripts that you created, which sounds like a good thing. I mean, reusability is an important topic in the IT world. But however, for test automation, what we noticed that the effect of this is that the test scenarios ended up being very expansive. So we saw test scenarios consisting of 100 or more separate steps, which turned out to which made it so the test scenario didn't properly describe or wasn't clear in what was actually being tested. So what was the action taken? What was the expected outcome? That sort of stuff. Another issue that we ran into is dependencies between test scenarios. So imagine that you have one test scenario that as a part of its scenario, part of its test, it makes a change to some piece of test data. And then you have another scenario that in some way or form is dependent on that change to be successful. This means that if for some reason the first test fails, the second test will also fail, which isn't that much of an issue if it's only 2 tests you're talking about and you know about the dependency, but it can become an issue quite easily when there's a lot of dependencies between your tests and you don't know about the dependencies after a certain amount of time. And finally, one of the major issues we saw is when looking at test automation frameworks or entire test suites, is that after some time they turned out to be these huge, complex, untraceable things where no one exactly knew what was supposed to do what and where the responsibility lie for certain actions, or where nobody dared to make any more changes to the framework because they simply didn't really understood how it worked. Yeah, so that's a definite example of something you want to avoid. So, looking at these common issues that we saw, obviously we learned from them. We try to create solutions for them, and I would like to present those solutions in the remainder of this presentation. Now, keep in mind that, and it might be redundant to say, but obviously there is no such thing as best practices in test automation. There are only good practices within a certain context. So what we saw, that the recommendations that we're about to give you turned out to be good practices in our context, on our projects, the type of applications that we worked on. But by no means are those recommendations any sort of law. So please take the recommendations that I'm about to give you and apply them to your own project if they are useful, if they add value in some way. Let's start with the first issue, and that is test architecture. Because what we saw is that there wasn't a lot of attention beforehand on how a test automation architecture should look like, what kind of levels there are, and what the responsibility is of each of these levels. What we noticed on most successful implementations is that there's a clear distinction between layers, with the first layer being the system under test, obviously. Now, this also isn't a layer on which you as a tester or a test automation engineer will be actively working on, but it is important to understand how your system under test works. What kind of access layers you have. So do you have a UI? Do you have certain services? Is there a database? That sort of stuff. And once you understand your system under test, you can start building a test framework or use an existing test framework in which you provide methods to operate the system under test. So if you have a web-based UI, you probably want some sort of web driver in your test framework. If you want to call services, you might want an API library, that sort of stuff. The next layer in the architecture is the actual test implementation layer. So this is the point where the actual technical implementation of your tests will be written. So for those already a little bit accustomed to test automation, this is the point where, for example, your steps or your pages will be in. And the test implementation only uses functions from the test framework. So it doesn't speak to the system under test directly. It only calls the test framework and basically delegates everything it wants to do to the test framework. And the test framework itself then talks or operates the system under test. To perform a test, you probably need some form of data in most cases. So there's also a test data layer with some form of data generator, or it might even be some sort of hard-coded data in some way or form. But your test implementation needs some input to provide to gain data in which to use in your test. And then at the top, you also have the test specification layer, which for a lot of us will be in a Gherkin format, which I talked about earlier, and which is a main topic of this presentation. And what you would like to do is actually keep a clear distinction between your test specification and your test implementation. So the test specification specifies what is being tested, and the test implementation provides how it is being tested. And the final layer, very important, is a test reporting layer, because obviously once you run your test, you want some sort of reporting, some form of way of knowing how your test performed, which tests are passed, which tests failed, and why those tests are failing. And the test reporting layer makes use of feedback from all the other layers in providing a clear report. What we saw, if you look at the test effort that you have, is we sort of see two sides to this architecture. On the one hand, you have a create side. This is where the primary testing effort will be. So this is the side where you will be creating new tests, where we will be implementing those tests, where you will be thinking and providing test data, that sort of stuff. And on the other hand, we call this the use layers, which is the test framework and the system under test. These are mostly layers which you set up once, and then you probably won't be touching a lot after that. which isn't to say that you will never be touching your test framework ever again. But once you've set it up initially, you want to set up in such a way that only when a change in your system under test actually requires you to change something in your framework, that's when you will be tweaking it. So most of your test effort will simply use the services provided by the use layers that are already in place. This might be a little bit abstract, so let's take a look at one of the most common seen test architectures out there in the field, I guess, which is the page object model, which again consists of several distinct layers, with the first being the features, which describes your test in a business-oriented language, such as given when then. The features then are implemented into certain steps, and those steps provide the functional implementation of your test scenarios. So every keyword in a feature file will be implemented in a single step. And what you would like to do there is keep it as functional as can be. So the method calls that you will see in the steps layer will be, for instance, log in as an admin, fill out a form, verify a message. Method calls that even for non-technical people are still understandable. Going one step further, one layer further, you will find your helpers in your pages, which provide the actual technical implementations of the methods called from the steps file. So here you will be actually calling a WebDriver, searching for elements on the web page, clicking on buttons, that sort of stuff. The test implementation layer, which I talked about in the test architecture slide, those are actually the steps and the helper pages layers together in this model. One layer further, the helper and the pages actually make use of services provided by the framework. So the framework is responsible, for instance, for providing a WebDriver, for keeping track of which WebDriver you want. Do you want a Chrome driver or a Firefox driver? Which version do you want? Do you want it to be headless? Do you want it to be mobile format? That sort of stuff. That's all the responsibility of the framework. And obviously the framework then talks to the system under test to actually perform the test. Keep in mind that while the page object model is a very strong architecture, which is also the reason why you see it on a lot of projects, it is by no means a silver bullet for every project there is. There might be other architectures such as Screenplay, which are more beneficial for your type of project. And also you can take an architecture and tweak it to your own needs. So let's say, for instance, you have a microservices architecture with very small applications. Is it then really necessary to keep a clear distinction between steps and helpers? Or can you provide this in one layer? I don't have the answer, but that might be something worth looking into, that sort of stuff. Again, there are no best practices, only good practices within a certain context. So that's to say, the test architecture is something as a first step, something you want to think about, something you want to make an educated choice when first starting your project. But simply by using a proper architecture isn't enough to keep everything maintainable. So what we're going to do, we're going to dive in what we call the 8 commandments of test automation to see what else is necessary to keep your tests maintainable. But before we dive into those 8 commandments themselves, let's first take a quick look at Gerwin, because that is an essential part of the remaining slides. And Gerwin is used, well, so far on every project I've been on, but we also saw a lot of different ways in how Gerwin was used. So it might be good to give a little bit of attention to that. And Gerwin provides 3 different keywords, given when then, with given being your baseline, every precondition that you need when performing a test. Then the when step will be the actual concrete action that you will be taking. So what is the action that you want to see the outcome of? And the then step being your actual expected result. It's as easy and as simple as that. So what we say is don't make it any more advanced or any more complex than this. It's supposed to be a concise way of writing tests, so keep it concise. And to prove that point, let's take a look at this scenario here. This is an example of a scenario that we encountered in a lot of the projects that we've been on. So here you see those small atomic steps that I've talked about when talking about the common issues. So you have a step for clicking a button, for clicking on a link, for filling out a field, that sort of stuff. It makes the steps perfectly reusable. But if this ends up to be a scenario with, well, a lot of steps, and like I said before, we've seen scenario with over 100 steps, then the whole point of writing your test in a concise format is lost. So what we say as a first commandment, a typical scenario should be 3 to 5 keywords long. If you take a good look at the scenario that we have here, if you take a look at this entire first part, then the whole point of all those steps here is to go to a certain contact form on a certain page and fill it out. That's an actual action. So in our case, this is actually a single action. You go to a form, you fill out the form. That's it. So instead of going through all the different steps, you can just go to the form directly, and you provide, in this case, one step to go to the form and fill it out. And your expected result is then I expect to see a confirmation page. So by doing it this way, we transformed this expensive scenario to a single scenario of only 2 steps, which is a lot more concise and a lot more readable, especially when collaborating with other people on your team. Another example when talking about atomic steps, and something we saw a lot, is a scenario such as this. The whole point of this scenario is to test whether removing an item from a shopping cart does the right things. But obviously, if you want to remove something from a shopping cart, then you need to have added something to the shopping cart first, which is, in this case, what the first half of the scenario is. But that also means that the scenario actually does 2 things. It tests whether you can add something, and it tests whether you can remove something. What we say is a single scenario should only describe a single test. So looking at the first part of the scenario, we can separate it as its own separate scenario where you add something to a shopping cart and then you check whether the expected result is achieved. And we pull this apart entirely from the remainder of the scenario where we remove an item. So the baseline condition in this case, which is shown with the given step, simply says the user has 1 item in his shopping cart. Looking at the 2 scenarios on the right, you have 2 a lot more concise scenarios, which are a lot more readable and a lot understandable, especially for people more on the business side of things. Going on to another kind of scenario that we encountered, and we worked together on an application which we made use of a content management system. So that means that editors can add documents to the system, which will then be transformed to web pages. So most of our test consists of uploading documents, then actually performing something on the web page, and then checking the actual results on the web page. And we saw scenarios such as this, where a user logged into the content management system, filled out a new document, published the documents, that sort of stuff. But if you look closely at why you need to perform all those steps, the only reason for it is actually just to provide some test data. It's only setting up your baseline condition, only setting up your test data. And what we say is a single test should be responsible for managing its own test data, but obviously in a more concise way. So all those initial steps that are taken here can be consolidated into a single given step saying given a content document. And obviously can provide different kinds of content documents here in this step. So a news page document, that sort of stuff. Which leaves the when step to only when the form in the document is filled, and the then step, the user sees a confirmation page. So again, a more concise scenario in which the scenario is itself responsible for its own test data. Now you might wonder, looking at this document, like how do you provide that test data? Well, let's dive a little bit further into that. So let's take a look at this feature file, for instance, where we have a scenario which says given a certain vacancy, when that vacancy is filled, then the user sees a confirmation message. If you take a look at how this scenario or how the single step of filling out the vacancy is implemented in the steps file, then we have the functional steps, the functional implementation that I talked about earlier. So we want to navigate to a certain URL. We want to accept cookies. We open the form and we fill out the data. But obviously at that point, we want some form of data to use to fill out the form. And what we see a lot was expensive Excel sheets to keep track of your data, loading out the test data from those Excel sheets. Well, we say to keep it simple, to keep a single point of truth, manage your test data primarily as code. So how can we do that in a certain step file? We simply say we have a vacancy form data class and we create a new one. And in some way or form inside this class, the test data is generated. And then we can pass that test data onto the fill data method. So you have a single point of truth now. Everything is, in this case, in Java, everything is in the same repository. Another issue that we frequently saw was a lot of test data being put into the scenario itself or into the test specification. While we say only control the relevant test data and generate everything else. So only put test data that actually relevant for your test into scenario. So it's clear when reading the scenario that that's the test data that's in this case controlling, and leave out all the other test data there is and simply generate that. So let's say for this test case, it is important to pass on a certain education level, and there's some other important field for the test where you want to pass in some data. Then only those two fields are passed in the scenario itself. All the other steps, and you see here that those two data points are passed here in the form of a vacancy form data, and all the other data is generated in some way or form. So we pass on the initial data. We say this is the data that actually implemented in the scenario, and all the other fields that are there in this vacancy form generate that data, and then pass on the data to the form itself. What this means is that your scenarios again remain a lot more concise, and also you can clearly see which data is relevant for the test that you're performing at this point. Moving on to another issue that we most frequently saw, and this is something that we saw a lot, especially on web-based applications. In most cases, you want to test your application on multiple browsers, on multiple formats. So let's say you want to test it on Chrome, on Firefox, on Edge, and you want to test it on a mobile format, on the tablet format, and on the desktop format. And what we saw was that the test specification was explicitly linked to the platform on which the test was run, or the format. So instead of having a single test scenario, you now quickly had 6 or more test scenarios, one for each of the browsers that the test was driven on. This leads us to the point where we say that the test specification should not dictate on what platform the test will be run. So looking at the example to the right, a more concise way of doing this same functionality is using annotations to show on what platform and on what format your test will be run. So in this case, this will be Chrome, Firefox, Edge, and on large, medium, and small. This makes sure that you don't get this crazy boom of the number of scenarios that you see in your test cases, because it's easy to lose overview of the tests you have once you get too many of these scenarios. Onto a relevant point these days, with more and more teams going, more organizations going DevOps, more DevOps teams being created. We do not only want automated tests, but we also want our automated tests to become a part of a CI/CD pipeline. So as a team, we can gain quick and valuable feedback on the work that we are performing. But it also means that you need to make sure that your test suite is in some way, in an easy way, integratable in such a pipeline. One way that we have done this is, for example, by providing several test runners, with each test runner being responsible for certain tags or certain annotations. So the runner that you see here, for example, is responsible for every test scenario which doesn't have the ignore tag, but does have the large tag attached to it. And this means that you can run a subset of your tests, for example, in parallel. You can run and you can call your test runners in parallel in your pipeline, and you have control over which tests are run at what point in your pipeline. And the actual command to run your tests, in this case a Maven command, is very easy. It only consists of a couple of keywords, and you can add a lot of control to which test you're running by adding parameters to your Maven command. So in this case, we say through a parameter that we want to run our test on Chrome. And we can provide another command where we say we want to run our test on Firefox. And we can make use of the same kind of parameters when providing whether the test should be run on the test environment or on the acceptance environment or on development environment, that sort of stuff. Which brings us to already the last commandment, which goes into test reporting, on which we say test results should be easily accessible and give leads towards solving possible issues. So you want your test report to not only show which tests are run and which tests passed and which failed, but also have your test report provide feedback to you whenever a test is failing. What steps can you take to make sure the test will be passing again? Where is the issue which made the test fail in the first place? So you can make use of a format such as this, which gives you a quick overview of all the tests that you were running, which of them were passed, but also an example such as this, where you can see on what format the test will be run, on what environment the test was run. And you can see here that one of the steps has failed, the when step in this case, and you can see a clear stack trace on what the issue was. And also very valuable at the very end, you can see those two attachments, which are screenshots, one of before the test failed and one directly afterwards. So you can directly compare the action that was taken to the outcome that was seen, which made the test fail. All right, which already brings us to the final slide and an overview of the 8 commandments that we define. You can see them here. I'm not going to read them out to you. You can read them on your own. And obviously, there's a recording of this session, so you can experiment with these in your own time later on. And yeah, which leads me to ending my presentation. And I want to thank you all for your attention. Also, one quick shout out to Mazin yet again for working with me on this presentation. And also I provided a GitLab URL here on this page, which links you to a test framework that we created, in which a lot of the functionality that I described, a lot of the options that I described in the commandments are provided by you by a framework. It's a Java framework making use of Cucumber and Selenium WebDriver. So if you want to take a look at it, if you want to use it, be our guest, basically. And that's it from me.
Okay, thank you, Joost. Very complete and clear presentation.
Thank you. Thank you. I had fun at least, so I hope everyone attending had fun as well.
I had fun as well, so we're good. Yeah.
Good.
Okay, unfortunately, there are no questions. So
Right.
there's nothing I can ask you. For me, it was a clear presentation as well. So again, thank you very much. And
And obviously, if people do come up with some questions later on, find me or Mazin or LinkedIn or on Twitter, and go ahead, ask ahead.
okay, hopefully they will do that. Okay, thank you. So for now, this concludes this edition of the Build Tech Talks. And this evening's sessions and all our future sessions will be published on our YouTube channel. So if you're interested in more of this, please subscribe to our to this YouTube channel or our Twitch channel. You can also sign up for the Capgemini Digital Meetup channel, and the meetup URL is shared in the description below. So thank you all for watching, and hopefully we'll see you next time. Bye-bye.
Bye-bye.